With LightStanza, you can generate USGBC compliant LEED scorecards quickly and easily using climate-based daylight modeling specific to the site location. We'll start this tutorial with how to validate the model for proper setup, and then we'll run an annual simulation to review the building's performance against LEED Option 1 and Option 2 requirements. Before running our simulation, we'll start by reviewing the calculation grid properties. First, we should start by turning off any unoccupied spaces. This will allow the calculation to run more quickly, as well as improve the LEED score by not considering spaces that don't have regular occupancy. For more information on what counts as an occupied space, you can review our daylighting guide at lightstanza.com. And we'll also confirm that our calculation grids meet the LEED requirement of 2-foot point spacing and a 30-inch work plane height. LightStanza creates the calculation grids automatically to meet these requirements, so we just need to double check in the editor, and in this case they're already set for us. Next, we'll review the site panel. The correct latitude and longitude are essential for accurate daylight simulations, so we'll double check those. LightStanza will automatically use climate data for the closest weather station. However, you can also override that in the climate data section if needed. With everything set in the modeling bar, we can now go to the activity bar and find the LEED scorecard under the calculate dropdown. And here we'll choose our LEED scorecard type. 2009 is an older simulation method that can still be used on certain projects, but for most projects we'll use version 4. We can evaluate option 1 or option 2 separately, or at the same time, and compare the results for both options at the end of the simulation. Option 1 also requires that automated blinds be considered during the annual simulation, so we'll just confirm that that's on here and start the simulation. And with our simulation complete, now we can see how well our design did by reviewing the LEED scorecard under this View Report option. The top of the scorecard reports the points given to the building for options 1 and options 2. Below, we also have a detailed breakdown showing the spatial daylight autonomy results and the annual sunlight exposure for each space in the model. In the report, we can also include and exclude individual spaces to see how that impacts the results. This is equivalent to turning off the inactive spaces as we did in the beginning. It just lets us do it here in the report without having to rerun the simulation. So you can experiment and see which spaces are impacting the report the most, and enable and disable as needed from here. And to conclude, we'll also review our simulation results in 3D for better context. Go to SDA for spatial daylight autonomy, and then switch to a downward view to review the daylight performance in each individual space. Thank you.